Hey everyone, welcome to my channel. Today we are going to decode a key concept in finance, CAGR or compound annual growth rate. It is an important measure of return in the financial world. Let us break it down. To understand better, we can divide into three components. Number one, compound. Not only the return on principal is calculated, but the return also added into that. Number two, it is always calculated on annual basis. Number three, the growth rate. It is a percentage change. The formula for CAGR is quite simple, but understanding the concept of compounding will help to learn all the financial concept. So we should understand the concept first instead of learning the formula simply. We have two types of interest rate, simple interest and compound interest. Usually, compound interest will be given more importance while studying any finance concept. The simple interest will be often ignored. Let us look at the difference between simple and compound interest with an example. Let us work it out in Excel sheet. Let us assume we have principal of rupees 1 and we are assuming the interest rate is 5%. For both simple and compound interest, the first year interest earnings will be same because we have rupees 1 as a principal and the interest rate coming out to be 5% on 1 rupee, that is 0.05. The total amount we are getting 1.05 in case of simple interest, and again in the compound interest also it is 1.05. Now in year 2, in simple interest, we calculate the interest on again on the principal of 1 rupee. So we get 0.05 again, making the total to 1.1. In compound interest, we calculate the interest on this new capital, that is 1.05. So we can earn the interest of 0.053. So the which make the total into 1.103, little bit higher than the simple interest part. Similarly, for the year 3 also, we will calculate in the same manner. We will calculate simple interest for the principal of 1 rupee. We will get again 0.05, making the total into 1.15. But in case of compound interest, again we are calculating on the new total, that is 1.103. We are earning more interest this time, 0.055, the total, making the total into 1.158. You can see here at the end of year 3 we earn little bit more when we use compound interest. This process continues over time, and over time the compound interest will yield more than in simple interest. Now you may ask me whether I need Excel sheet to calculate compound interest. No, without even having the Excel sheet you can able to calculate compound interest. How we can do that? Let us see that. So now you have 1 rupee. It will become 1.05 at the end of year 1. That is what we have seen in Excel sheet, right? We had 1, now it will become 1.05 with the rate of interest of 5%. It will become 1.05. At the year 2, end of year 2, it will become 1.05 square. How it can be calculated? So in every year, if you have 1, it will become 1.05 in every year. So we have already seen that the simple interest and compound interest will be same for the first year. If you have 1, it will become 1.05 at the interest rate of 5%. But in taking the compound interest, at the end of year 1, we have 1.05, not 1, right? Now I have 1.05. So multiplied by 1.05. I will get 1.05 square at the end of year 2. That is what I have written over here. At the end of year 2, it will become 1.05 multiplied 1.05. We get 1.05 square. That is turned out to be 1.103. That is what we have received here. You can see this is basically 1.05 square. It will be 1.103. Similarly, for year 3, it will become 1.05 cube. You can say like this because I have already I have 1.05 square. So if I have 1.05 square, if I have 1.05 square, then at the end of year 3, I can have 1.05 square multiplied by 1.05. So I will get 1.05 cube at the end of year 3. That is what I have written here. So it turned out to be 1.158. You can see that also 1.05 to the power of 3, we get 1.158. So far, we have calculated the compound interest for the principal of rupee 1 and the interest rate of 5%. So what if I have the principal of rupees 5? So simply if I change 5 rupees, then the compound interest part is changing and the total amount is changing accordingly. Similarly, if the interest rate is 10%, then compound interest, what will be the compound interest? I can calculate easily using Excel sheet. And how we can calculate without Excel sheet? That we will see here. We can calculate compound interest simply using unitary method. How? Let us see that. If 1 become 1.05, that we have seen already, 1 become 1.05 after 1 year. So instead of 1, now I have 5. Then 5 become 5 multiplied by 1.05. This is as simple as that. Similarly, after 2 years, 1 become 1.05 square after 2 years. Then what if I have 5 as a principal? It will become 5 multiplied by 1.05 square. So that is how we calculated using Excel sheet. I will put 5 here, 5%. You can see after 1 year, I will get 5 multiplied by 1.05. We get 5.25. Similarly, after 2 years, 5 multiplied by 1.05 square, I get 5.513. We have calculated without Excel sheet here. 5 multiplied by 1.05, 5 multiplied by 1.05 square. You can be able to calculate even using the calculator also. There is no need for Excel sheet. Now we have calculated the compound interest. Have we used any formula to calculate? No. We have learned the concept of compounding. Using that concept only we have calculated. Now we can even derive the formula for compound interest based on the concept that we have learned now. How we can do that? Let us see that. We have seen already this one, right? 1 become 1.05. So how we can write 1.05? It is simply 1 plus 5%. That is how we have arrived 1.05. Similarly, for 1.05 square, 1 plus 5% the whole square. So what if I have 5 as a principal? Then we can write as 5 multiplied by 1 plus 5% the whole square. So this is the common format for compound interest. From here, we can derive the formula. Here, the principal, which is 5 rupees, it is getting compounded at the rate of 5% for 2 years. This is the principal P, this is the interest rate R, this is the period N. So we can generalize it now. How? If we have the principal P, when it is compounded at the rate of R percentage per annum, we get this total amount after a period of n years. This is the total amount we will get after a period of n years. So if you want to know the interest part, that is the compound interest only, we can simply deduct principal from this total amount. You get the compound interest. So this is the future value. Then if you deduct this principal amount, that is the present value, you get the compound interest. Here we say P is a present value, and this amount is inside the blue box is future value. That is the value after n years. So in a generalized form, we can write it as present value, that is the principal when it get compounded at the rate of r percentage per annum for the period of n years, we get future value. This is the generalized format for the compound interest. Whenever the any asset is getting compounded, we can use this formula to calculate its future value. We have actually started the discussion of the CAGR in this video. In this generalized format, this R is CAGR. This is CAGR. So let us go back to the Excel sheet to check this out. So this Excel sheet, we have calculated this one. We have already understood this one, right? So now we had an asset which is having the present value of 5. That asset is growing at a CAGR of 5%. That is what I told. Or then for a period of n years, that is 3 years, we get the future value of 5.788. This is what we arrived here. We can calculate using this generalized form. How we can do that? Present value of asset when it is compounded at the rate of 5% for a period of 3 years, we get 5.788. So this is the CAGR for this particular asset which is having the current value, that is a present value of 5. So in this format, you can see in this format, I will show here, we have 4 variables. One is present value, future value, CAGR, and the period. So if we know 3 variables, we can able to calculate the unknown value. That is how it works. So suppose I know present value of this asset and I know the future value of this asset, then I can able to calculate CAGR if I know the number of periods. We can check this using an example. Here we have an asset for which the present value is 50 and we are expecting the value of that particular asset will be 75 after 5 years. That is the future value of that asset. Now, based on our assumption, we have to calculate the CAGR for this asset. So now we will go back to the formula page, then we will see how it works. So this is a generalized format. Now we know this PV, we know FP, we know the number of years. We have to calculate CAGR. 3 known variable, 1 unknown variable. So it is just a mathematical format. Just we have to push this PV here, then we will get this format 1 plus R to the power of n equal to FB by PV. Then to cancel out this n, we are multiplying by 1 by n both sides so that it can get cancelled. Then it will get this form 1 plus R equal to FB by PV to the power of 1 by n. Then we push this 1 to the other side and we get R equal to FP by PV whole to the power of 1 by n minus 1. This is the formula for CAGR. We have learned the concept and we have derived the formula for CAGR from that concept. Then now we can check this formula in Excel sheet. So this is the future value divided by present value whole to the power of 1 divided by number of years minus 1. There we go. We got a CAGR for this asset for which the present value is 50, future value is 75.
If you found this video useful, hit the like button and subscribe to my channel to learn any finance concepts within 15 minutes.